Hello guys, so welcome to channel Run Basic. So in this video, we'll learn about composition of functions. So example, we have functions f and g, and their composition is denoted by f composed of g of x, this one, f composed of g of x, or we can read it as f of g of x, or we can write it this way. So f of g of x. So composition of functions can be part of an operation concerning your functions. Okay, so the process of obtaining composite function is called function composition, or in some books you can say that composite functions are known also as functions of functions. So just like you're evaluating a function where we substitute or input values of x to our function, so this time we will input, instead of a number or a value to our x or f of x or any function, we will input another function to a function, such as on our first example, we will input g of x to f of x. So let us start. So we have f of x. So to make it easy and simple, let's try to write our f of x. So f of x given. So we have x plus 5. So on evaluating functions or evaluation function, we input example x equals to a certain number. So this time x will be equal to g of x. So instead of writing x, we will substitute again. We will substitute. So instead of x, x will be substituted by g of x. So this is the process of the composite function or composition of functions. Okay? Continuing, what is your g of x? So g of x is given on the board. So we have g of x equals to 2x minus 1. Then substituting, we have g of x equals to 2x minus 1. Copy your constant 5. Then gemdas or pendas. So we will operate first inside your parentheses, but looking 2x minus 1, we don't have any operations to be performed. So let's proceed to exponent. So we don't have any exponent. So we will just copy and let it out sa aton nga parentheses. Then we have to combine like terms. So we have 2x. So 2x, there's no like term. Then we have negative 1 plus 5. So negative 1 plus 5. So the signs are not the same. And we are adding. So we will subtract 1 from 5. So we have 4. Then the greater absolute value between 1 and 5 is 5. Of course, we will copy the sign of your positive 5. So the correct answer is 2x plus 4. So the composition of f and g of x is 2x plus 4. Okay? Okay, let's try another example. So another example will be, let's find the composition of g of f of x. So guys, just to emphasize the denotation of this one, comparing to your multiplication. So multiplication is a solid circle or a dot, while your composition, we have an open circle, denoted by again an open circle or a small letter O, while your multiplication is denoted by a dot or This one. A closed circle. Okay? Let's go back again to example number 2. We have to solve for g of f of x. So the first example is f of g of x. Second example will be g of f of x, and that will be denoted by g of f of x. Again, we will use the function g. Example number 1, we use the function f and input g of x. So the input will be the last function. This time the last function is f, so we will input f of x into your g of x. So copy g of x. So we have 2x minus 1. So instead of x, we will write a parenthesis. So this is your g of x. So 2x minus 1. So instead again of writing x, for g of x is 2x minus 1, we'll write your parenthesis and input f of x. Okay? Continuing, we have 2 times the quantity of f of x, which is equal to x plus 5, and copy your constant negative 1. Then, gemdas. So we don't have any operation inside your parentheses, but we have positive or x plus 5, but we cannot operate. Then we don't have any exponent in here. So let's proceed to multiplication and let's distribute 2 to the quantity x plus 5. So 2 times x is 2x. Then 2 times 5 is 10. And bring down your constant 1. So we have 2x plus 10 minus 1, common sense, very basic. So we have 2x, then 10 minus 1 is equal to positive 9. So that is the composition of g of f of x. Okay? So very easy. Okay, let's try another example. Define for the composition of h and f of x, or the composition of h of f of x. Okay? So we will use the function h and input this one, f of x to h of x. So following h of x, we have this one, x squared plus 2x plus 2. So following, again we have the input f of x. Okay? Continuing, we have f of x equals to x plus 5. Then square plus 2 times the quantity of f of x, which is again x plus 5. Then copy your constant 2. Gemdas. So inside the parentheses, then exponent. Okay. So let us start with this one. So x plus 5 is a binomial. Then we have to square this binomial. Then the product will be a trinomial. So the product of squaring some difference of binomial is a perfect square trinomial. So when we say perfect square trinomial, the first term is a perfect square and also the last term. Okay, so let us first get the first term. So this will be a shortcut. So first term squared. So we have x squared. Then we have your last term 5 squared, and that is 25. Okay, your middle term will be x, the first term, times the second term, which is 5. So x times 5 is 5x times 2, and that will become 10x. So if the sign is positive, all of the signs of your trinomial will also be positive. Okay, if you cannot follow the shortcut step in this one, you can perform this x plus 5. by expanding it, x plus 5 times x plus 5, and do the FOIL method. Doing the FOIL method will give you this one. So we have to distribute the FOIL method. We have f x times x squared. Okay, then O, the outer, x times 5. So that will be 5x. Then the inner 5 times x, so another 5x. Then we have the last terms, L, 5 times 5, 25. So 5 plus 5 is 10. We are doing combining like terms. So again, another name of your FOIL method is smile method because just like this one, we are drawing or writing smile. Okay, let's proceed. So we are done with x plus 5 quantity squared. Now let's proceed to plus 2 times the quantity of x plus 5. So we have to distribute 2 to the quantity. So we have 2x plus 2 times 5. We have 10. And copy your constant 2. Then combining like terms. So it's the like term for x squared. So we have none. So just copy x squared. Then your linear terms, 10x and 2x are common or like terms. So 10x plus 2x is 12x. Then we have your constants, 25 plus 10. That is 35 plus 2. So we have 37. So very easy. So that is how to solve for decomposition of your function. So I hope and guess that you have learned something on this video. So stay safe and God bless.